Hey guys, Christian here. Welcome back again. We've got a graphing question today, which I know everybody really hates. It's kind of the bane of the existence type thing, so I thought we'd take some time and go through it. This question's given to us in what's called power form, right? Which basically means we've got a set of brackets to a power. It can be a relatively high power. It doesn't actually matter at this point. We've got a constant, which is added or subtracted at the end, and the bracket set is multiplied by some kind of coefficient. Surprisingly enough, these are actually quite easy to graph. They're pretty straightforward when they're written in power form. The trick is not every function can be written in power form. When they can be written, it's pretty straightforward. If you think back to your quadratics, right, you learnt turning point form, which was basically giving you the turning point of your parabola. Now, power form works in exactly the same way. It's just that the powers dictate the actual shape. Relatively speaking, it's actually straightforward. Even powers will give you a parabola-looking shape. Admittedly, the sides will be steeper and the base will be flatter than your average parabola, but any even power will give you a similar concept. Power of 4, power of 6, power of 8, power of 150 will give you this bucket-type shape. Odd powers, on the other hand, will give you the cubic type shape, admittedly, again, with the flatter baseline. But if you keep that idea in your head, these are actually pretty straightforward. You can find what I call the turning point, or the central point. All right, so we have a center, and that is given by the coordinates both inside the bracket and outside the bracket. You treat them like transformations. So when they're inside the bracket, it's usually a horizontal shift, and it's usually the reverse of whatever number's in there. So when you've got an x minus 4, that means it's shifted 4 units in the positive direction. The minus 12 on the outside, however, actually does mean 12 units down. Now, the coordinates that I've given here are actually the center of our graph. Irrelevant of the shape, the center is going to be where the graph is literally centered. If it's an even power, it's going to be the literal turning point. If it's an odd power, it's going to be the inflection point, but it's still the center of the graph. Once you've done that, considering we don't actually have to work out intercepts, there's not really much else to do. We think about the overall shape. Now, it's an even power, so it'll be a bucket shape. There's no reflection, so it'll be a positive. We can get a very quick sketch, and again, very quick. You should definitely be using a ruler for this when you do it properly. And we can say that the center is located at 4 and negative 12. So the center of our graph is located right here. Now, without working out any intercepts, very simply speaking, I can say that the graph will look something like this, with a relatively flat bottom, and then back up again. That's all there is to it. If you wanted to work out intercepts, great. The power of the 1/3 out the front will dilate your graph, so it won't grow as rapidly. So without that 1/3, you can imagine it probably looks something a little bit more like this. Right, the 1/3 is sort of like narrowed it down a bit, but it's still growing relatively rapidly because it's a quartic. There's no way around that. However, considering you don't have to work out intercepts, you don't really have to give a lot of scale here. So the fact that you've got a relatively right shape with the translations proper, and it's definitely positive and not negative, that'll get you the marks you need for this question. If you want to see dozens more questions like this, as well as video lessons on how to actually learn this content, tech calculator lessons, the whole 9 yards, jump inside of the program Making Sense of Methods. I look forward to seeing you guys in there.